Let's try to understand I2C protocol on ESP32. We'll connect a sensor DHT11 to a display which is I2C LCD display. DHT11 is a temperature and humidity sensor with 3 pins: VCC, ground and data. Data pin is generally connected to GPIO. VCC and ground are connected to VCC and ground of ESP32. I2C LCD display has two important pins, SDA and SCL, which are useful for I2C connection with the ESP32. Now we'll try to understand the connection. So DHT11, as we have already seen, is connected to GPIO4, and I2C LCD is connected to GPIO21 and GPIO22. So clock is connected to GPIO22. The next step after doing the connection is to understand the code. In this connection, ESP32 acts as a master, while I2C LCD display acts as a slave. Now every slave can have different address. It is advisable initially to check at which particular address we are connecting the I2C display. I2C scanner helps you verify, is the wiring correct? Is the slave actually responding, or what is its correct I2C address? Sometimes I2C addresses are different and then we are unable to connect to the device. Let's understand how. It tries all 127 possible I2C addresses starting from 0 cross 01 to 0 cross 7F. It sends the start address and a write request. For each address, it performs all these things and then waits for the response. Looks for the acknowledgement from a device. If the device is present at that address, it will reply with acknowledgement, otherwise not. So finally, it will print all the addresses that respond, like as you can see here, I2C device found at 0, 27. This means that your I2C device has an address 0, 27. Important libraries you need for working with I2C on ESP32. When working with Arduino IDE, the main important is wire.h. It provides you wire begin SDA, SCL, with which you can configure any of the I2C pins as SDA and SCLP. You can use begin transmission and the address to start writing to the I2C device. Then write will send the data. End transmission, you can stop the transmission. Request form, when you want to read the data from I2C sensor, you can use the request form device and then you can read the bytes from it. So if you use Arduino IDE, this is the only required I2C library working with ESP32. Two additional libraries required in this case are the liquid crystal underscore I2C for the LCD display and DHT.h for the sensor. Important instructions in this code are: first is liquid crystal underscore I2C LCD at 0 cross 27, 16, 2. Here 0 cross 27 is the address at which we have the LCD display, and 16, 2 is the size of the LCD display. Wire begin is the instruction which is used for the I2C communication, where 21 and 22 are the SDA and the SCL pin on ESP32 used for the communication. Once you upload the code, you will be able to see the communication happening between the sensor, the microcontroller and the LCD display. The sensor readings can be visualized on the LCD display. Whenever you change the sensor parameters, you can see the immediate changes in the LCD display. So this is how I2C communication happens.